Hello friend, welcome to Engineer Adda. Today we are going to see analysis of frame by using cantilever method. So let's start. Here it is given that all the members is having same cross sections, means the area of all these members is same. So let's start. Our first step is location of centroidal axis. So we know that by using this formula we are able to calculate the centroidal axis. So why we have to calculate centroidal axis? Because it is our assumption that we see this assumption in our last video, that is see directly the second assumption, that is direct stresses in the column due to the horizontal forces. Stresses in the column due to these horizontal forces are directly proportional to their distance from the centroidal axis. Hence we have to find this centroidal axis first. That is our first step. So by using this formula directly we calculate the centroidal axis. We know that is x bar, means the distance of centroidal axis from any of the corner. It is a1 x1, area of any one column, into its distance from any one corner, plus a2 x2 plus a3 x3 divided by whole area. So here in 7a, that is we know that all the cross section area of all members are same, so we take it as a. So 7a means the distance into area 10.5a, total 7 plus 3.5 means 10.5, distance from this 10.5a and 15.5a. so it is the distances from this left hand side column. So we get the centroidal axis, that is x bar equals to 8.24 meter from left hand side column. Now moving towards our second step, that is the calculation of axial forces in the column. So we have two story, that is this first story and the second story. So for the second story calculation, for the top story calculation, so we know that second assumption, what the point of contraflexure in the all the member lies at the mid span. So point of contraflexure is lies at the mid point. Suppose the section is passes from the mid of the span. What section we represent here? Sorry, section is passes through this mid of this span because point of contraflexure lies there. So this is the shear taken by the column and this is the axial forces. As we know that from our, so this is the distance of this column from the centroidal axis. So we know that from our second assumption that direct stresses in the column due to horizontal forces are directly proportional to their distances from the centroidal axis. So it is nothing but the stresses in the column. A is the area, V is the force, V by A means nothing but the stress divided by a distance, that is x1 from the centroidal axis. So it is our second assumption, that is direct stresses in the column are directly proportional to their distance from centroidal axis of the frame. So this is our second assumption. Mathematically it is represented like this. So it is our second assumption. Now all the areas are same, that's why cancel it. That is we got v1 by x1 equals to v2 by x2 equals to v3 by x3 equals to v4 by x4. So just put all the value. We know x1 from this figure, x2, x3, x4. So we get this one, we get this one. Just make sure that all these unknowns in only one form, that is v2 in v1 form, v3 in v1 form, v4 and in v1 form, that is v2 into 1.25 into this. Just cross multiplication, take this 2, take this 2, take this 2. So we get v2 equals to 0.15 v1, v3 equals to 0.274 v1 and v4 equals to 0.881 v1. So here now we have to calculate this forces, these forces. Now we have to calculate these forces, that is axial forces in the column. So I'm drawing this diagram here. See, this A, B, C, D, and these are the axial forces. This is the centroidal axis, x1, x2, x3, and this is x4. So we have to take moment x equals to 0. So this is all forces and this is P1 acting here. So we have to take moment here. We have to take moment here, that is V1, V2, V3, V4, summation of moment. You have to take summation of moment here equals to 0, that is V1 into x1, so what I represent here, plus V2 into x2, what I represent here, plus V3 into x3, V4 into x4, and P1 into h by 2. So this is nothing but h by 2. So P1 into h by 2. Just put all the value. We know x1, we know V2 calculated here in terms of V1, that is 0.15 V1. We know x2, V3. Just put all the value what we know. We directly get the value of V1, and from this V1 we are able to calculate V2, V3 and V4. So it is so simple. Likewise, we have calculated all the forces or the axial forces in the column of top story. Now same calculation is made for bottom story, that is section is passes from the point of contraflexure. So this is the forces in the column, same as previous one, and we here take the moment at this point, so this is total summation. This is same like this, that is V1 x1 plus V2 x2 plus V3 x3 plus V4 x4 equals to P, that is P into this 3.5 plus 1.75 plus 180 into this 1.75. So we directly get V1 equals to 61.119 kilonewton. By using this we are able to calculate V2, V3 and V4. So now up to this we just completed our second step, that is the axial force in the column. We have calculated axial force on the top story, axial force in the column of top story and the bottom story. Now we moving towards our main calculation. Our main aim was calculating the shear force, axial force and the moment in all the members. So I think this is one of the simple method what I take here, that is by joint method. Joint method is one of the simple method for solving a cantilever type questions. So take a joint A. So this is joint A. This is the point of contraflexure here and the point of contraflexure here. Just make, that's why this is shear taken by beam and this is nothing but shear taken by column. This is the axial forces now, and this is outward forces. So just take clear in your mind, we have to take here only three types of operation, that is firstly summation of Fy equals to 0 on this joint, summation of moment equals to 0, and summation of Fx equals to 0. By only doing these three steps we are able to calculate whole forces on this joint. So let's see how we do it. Just take summation of Fy equals to 0. Initially just take here, I'll draw A. Initially I have 120. This is axial force unknown, V1 equals to 13.607 I don't know what is. Initially I just take summation of Fy equals to 0. From this I get some force is required to balance this force. So for that force is act here, that is I represent this force by V. So by vertical summation I got minus 13.607 plus V equals to 0. So I got V equals to 13.607. Now second, that is just taking movement equals to 0. So I take movement here, represent this here. I take movement here, that is this is I calculated what 1.75 and this is 3.5. so I take movement here because this is point of contraflexion, so movement about this point is same, that is 120. If I take clockwise as positive, 120 into 1.75, that is 120 into 1.75 and minus 13.67 into, that is this V1 into 3.5 and one force, horizontal force here, that is minus H into 1.75. By doing this I directly get the value of H, that is what I represent here, 92.786 kilonewton. So likewise I have to calculate here. Now the third step, that is summation of Fx equals to 0, all the vertical forces equals to 0, that is here, sorry, there all the horizontal force equals to 0, that is 120 H1 and H1. So we directly able to calculate the value of H1, that is 27.214 kilonewton. The same procedure is applied for the joint B. Same procedure, just remember that we have to take only 3 operations, that is first summation of Fy equals to 0, summation of moment equals to 0 and the summation of Fx equals to 0. Just now we are taking joint B, so it is joint B. All the forces what we calculated in the joint A, that is we calculated V as vertical and this H as in this direction, so here equal and opposite, hence V is downward and this reaction in this direction, that is 92.786 H1 and this is downward, so it is equilibrium condition, both are equal and opposite. And we know here V2, that is 2.041. Now we have to calculate, firstly apply Fy equals to 0, that is Fy equals to 0, we directly get this V1 here, this V1 we directly get this V1 15.648 kilonewton. Now movement at this point, apply movement at this point equals to 0. We directly get H1, that is only one unknown because I applied, if I apply movement equals to 0, this H2 becomes 0, only one unknown. I directly get the value of H equals to 49.924 kilonewton. And after third step, that is summation of Fx equals to 0, summation of Fx equals to 0, so we get H2 equals to 42.862 kilonewton. Just same. So now also consider joint C. We could just completed joint A, B. Now moving towards C. Same operation is applied. Initially summation of Fy equals to 0, summation of moment equals to 0, and then summation of horizontal force equals to 0. By using same this step, by applying same this step, we are able to calculate all the unknown, that is vertical shear in the column, vertical shear in the beam, axial force in the beam, and this is axial shear in the column. So same procedure applied for the remaining all joint, that is now joint C. So this is the values for joint D. Just we sure that whether our this calculation joint A, B, C, whether this calculation is right or not, we find out by joint B. Because if we take here summation of Fy equals to 0, we get this one. We get this one from this figure, that is 11.92 equal and opposite, and we know that we are calculating V4 here 11.94. so this is summation of Fy is 0 minus 11.92 plus 11.92 0 means it is in equilibrium, means what we step did, that is what we solved, joint A, joint B and joint C, this all are correct. We get from this equation. If this is not correct, if this is not, we got 0 answer here. If we got here 1 2 3 4 means I am done something wrong in the previous calculations. Now moving towards bottom story, the same calculation, that is summation of Fy equals to 0, summation of movement equals to 0 and summation of Fx equals to 0. Just concentrate on this figure. If you draw this figure accurately, you are going to get accurate answer. Just make sure that this joint is in equilibrium, hence what the reaction is transferred from the upward side or from the downward side is exactly equal and opposite. Just solve joint E by applying 3 operations, joint F, joint G, and whether we are getting right answers or not answers, right answer or wrong answer, we are able to find out this from joint H. Here the vertical summation is 0, that is 41 minus 41 minus 11.85 is equals to 53.8 53.916, means this joint S is in equilibrium, hence what we calculated is exactly right. So this is the representation what I calculated. All these movements, all these vertical shears in beam and shears in column, I represent in this diagram. Now how to calculate movement? Once we calculate the shear here, that is I am directly able to calculate the movement. No, movement in AB is nothing but the shear taken by it, that is 13.607 into distance. Distance means this L by 2. So what is this distance from A to B? A to B is 7, so 7 by 2 is directly get what I get here, 13.607 into 7 by 2. I get 47.624 kilonewton meter. This is nothing but the movement taken by A to B, same movement taken by B to A, that is 47.624 kilonewton meter. The same if we have to calculate the movement from B to C, same movement from B to C is 15.648 into this distance by 2, that is the distance of this is 3.5. This is nothing but the 3.5 divided by 2, so we get 15.648 into 3.5 divided by 2, so we get here 27.401 kilonewton. So likewise we are able to calculate all the movement, that is movement from C to B, movement from C to D, D to C, movements in column, movements here, all are we are able to calculate. See here I am just taking example, movement from F to G. So now you are able to calculate all the movements F to G, that is 54.731 into 3 by 2. So this is nothing but the movement pair by that B, that is 54.731 into 3.5 divided by 2. 3.5 divided by 95.779. So this is nothing but the cantilever method. This is very easy. Just remember that we have to do only 3 operations on each joint, that is summation of Fy equals to 0 initially, then summation of movement equals to 0, and then summation of horizontal forces, that is Fx equals to 0. By just doing these 3 operations on each joint, we are able to calculate all the shear force in the beam and column. And after calculating all the shear force in the beam and column, just draw this diagram, and from this diagram now we are able to calculate the movements. So thank you.